I tried my best to get Einstein here, and I ended up with this, so I'll just cover it up with the cap. So let's get this started with quantum mechanics! Now, there's only one thing that physicists have discovered in the last 100 years, is that the universe is even weirder than earlier scientists have expected. So Einstein's theory of relativity, as we've already talked about, well, unless you've read it already, showed that reality didn't actually have to match up with our daily experiences. Time and space could be experienced differently, or they could be experienced at the same time. You can look them at different points of views, and they'll look completely different. You can basically time travel, but only short amounts of time right now. And this theory is showing that, it can show things being in two places at once, and it, behaved in two different ways. It's at the same time. This one thing can be these two things at the same time. This thing is called quantum mechanics and superposition, and I'll explain what all that is. Now, what is quantum mechanics? And now lots of people think that it's incredibly exciting. True, but it's also extremely complicated. Not that complicated, to be honest. I was originally one of those people. Now, it's not really that much. Now, first, quantum mechanics. Quantum mechanics is all about the very tiniest particles, even smaller than a grain of salt, or even smaller than an atom, or even an electron. In fact, they're so small that we can't even draw them at all. Also, they're usually drawn as little spheres. They're usually not little spheres, too. So, how do physicists actually make sense of quantum mechanics? By using a lot of math! Great, I'm good at math. Show me. What kind of math? Math is cool. Our brains can actually use these little symbols and drawings and numbers and symbols to actually make clear of things, make heads and tails of things that aren't even real, are just in our imagination, or we can't even draw pictures about. All we can do is think about them. So, if I give you an example like this one, oh crikey, you might think. It's actually not that complicated. All you have to know is what each symbol means. And I'm really far away from that right now, so yeah, I just started trigonometry. Do you think I can do this? No. Well, at least not yet. I think I'll win grade 9. Don't you mean it's about probability? Yeah, basically. It's exactly it's about probability. What's most likely, what's not likely at all. Now, quantum basics. Electrons and light. Now, electrons and light, let me show you something. So let's try shining bright light. And let's say we're trying to put a frequency of light we're using. So let's just say we increase the frequency and we even give a brighter light. So what we see happening right here is the exact opposite. The brighter light gives us more electrons, while the higher frequency light gives us more energetic electrons. So is light a particle, or is it a wave? Technically, it's both. I like to imagine like this: a photon that moves up and down through space like a wave. Which is kind of weird. So I'm not even going to debate about it here this episode. It's the middle of the night I'm recording this. It's the middle of the night. And electrons can get very excited too. It's one of the most important things for electrons is that if it gets too excited, it goes up. And if it gets not that excited, it's at the bottom. And back to quantum mechanics. Remember that thing I talked about probability? Well, the probability is basically about wave functions. Let me take an example of a cat. Yeah, let's just go for cat. Now, the cat is vacuuming. Not likely at all. The cat is flying. That's very unlikely. The cat is sleeping. Quite likely. Sure. The cat is running. Quite likely. The cat is meowing. Very, very likely. The cat has big blue eyes. Very, very likely. Yeah, also sometimes they're like big blue and black eyes, so it's very likely too. Now, these are all possible things. And these are all the possible things that could be happening to the cat right now. And it's called wave functions. But the wave function breaks once you observe it. So until you observe what the cat is doing right now, it could be all of these things. Now, of course, there are some theories about what happens just before you observe them. I'll just tell you about two of them. One of them is called the Copenhagen interpretation. It's basically saying that a particle can be all of these types of things, all of these different kinds of things, all these possible things at the same time until you look at them and then all the other things shatter away and it's only this one. Well, another person calls the many world interpretation. This is the one, it's my favorite because it includes the multiverse. And I really want to go to another universe where I've been a good son. So yeah. And in this many world interpretation, it basically says that until you've observed it, each possible thing that could happen to this one particle is in its own separate universe. Like, here's a very good, interesting video. Like, Outlands Out made a video about the multiverse. Really, this is very similar to this one. Basically, it says that if you did option A in this universe, in the other universe, you're basically doing option B. In this case, this is what happens. Until you observe it, it's both A and B. In this universe, it might be A or it could be B. In another universe, it could be A or it could be B. So, this universe A, this universe B, this universe C, this universe D. And until you observe it, all these universes exist. Now, we don't know what happens to these other universes. If you observe it, they might shatter or get destroyed. Or if you don't observe it, and if you observe it, then all these other universes have all these possible solutions, and then it goes branches out, and that's what the multiverse is basically. And yeah, so even if you're using quantum mechanics, you can basically go quantum tunneling. And quantum tunneling, you're basically having the time of your life. You're tunneling into the unknown, and that's how you use the scanning tunneling microscope to actually see special types of particles. And this is also how quantum computers can make a quantum internet. Now, let me just tell you about what quantum computers are. Quantum computers are basically computers, but instead of using the regular 0-1 bit, they also have a superposition called the qubit. It's both 0 and 1 at the same time. Now, this can lead to so many new things. Regular computers, like, let's just say how it solves a maze. It tries every possible solution, and it stores every false solution and every correct solution. While a quantum computer would do this, it would try every solution at the same time, and it only memorizes the ones that are correct. So, this one would be like, error, go back. Error, go back. Error, go back. Correct. And it memorizes all these patterns, all the things that it tried. However, a quantum computer will basically, oh, 2 paths. Let's split this. Go down. Oh, this one's wrong. Delete. Oh, another one. Split. This one's wrong. Delete. Another path. Split. This one's wrong. Delete. And then we know that this one's correct. And it only memorizes the correct ones. So that's how you can crunch data faster. Also, quantum entanglement is when, like, they say this is 0, then this will become 1. But it only happens in superposition, so you can't see it to make it entangle. And it's really hard to entangle loads of qubits together. However, if we do, you can make a Wi-Fi-less internet. Basically, like, anywhere you can become it. Like, let's say you're somewhere near the sun. You can quickly log on to something in less than 1 second. That's happening on Earth. That's happening on another quantum computer that's on Earth. That's the great thing about entanglements. Like, you don't know which, like, there are 2 boxes. One of them is a white marble and one of them is a black marble. You don't know which box you put in, which box has a white marble and which one has a black marble. You push the one with a black marble away into the sun, and then you open the one that's near to you. You find out it's a white marble, then you instantly know that the other one is a black marble, unless, like, someone cheated. So that's pretty much all we have for quantum mechanics. So in our next episode, Chapter 6, Space. Note, it's middle of the night, so next 2 episodes, I'm going to record this next morning. So, different clothes. See you guys soon. Not now. Peace.